Hello. In this video, we're going to basically talk about how do we plan for the inventory needs a company might need to decide in their planning horizons. So one of the key straightforward way of handling inventory planning is called economic order quantity model, EOQ model, right? So chapter 16 does a great job talking about other models as well, but due to the time limitation, we are going to be focusing only on EOQ models in this class. So EOQ models have certain assumptions that has to be there so that we could do the necessary calculations for planning the right inventory levels. So this video is going to talk about what those assumptions are and how do we derive the optimal formula for the EOQ model. So let's get started. EOQ model assumes, first of all, that you have a continuous review systems in your company, meaning that that has to be a simple or sophisticated technological way of monitoring the inventory positions of your stock keeping units in your system. So those could be like barcoding systems, those could be RFID systems, anytime you make a sale, it has to be deducted from your inventory position. Anytime you had an incoming shipment, it has to be added to inventory position, and it has to be monitored continuously. Okay, so that is the fundamental, one of the fundamental assumptions of running EOQ models in your system. Um, and then other ones are, so EOQ models, they work on single product at a time. So for a specific stock keeping unit or the family that you are concerned with planning, you have to run different EOQ model for each one of them. And we assume that in the EOQ model, we assume that the demand is known. So we do have a demand pattern, for example, like 5 a day, 5 a year, or 5 a month, whatever that demand rate is. We assume that it is stable, it is known. And yes, uniformly is the keyword here. It means that the rate is constant, it's not changing, and it is known. And the lead time, remember, the lead time is the time that you initiate the order to get your product or service from your customers and the time you got that order. So the difference between those time stamps are going to give you the lead time. So for example, I ordered my dinner today at 5 p.m. and I received it by Uber Eats at 5:30. So my lead time would be like just half an hour, right? But usually when it is coming from overseas, it is not really abnormal to see a month-long lead time. So it's very important to put together your planning with those large lead times, especially if you're dealing with multiple different SKUs, it becomes harder and harder to deal with. But in the EOQ model, we assume that the lead time is constant and known. So it shouldn't be like 5 days this time I order it, and then 7 days I order next time. So it has to be fixed. And we assume that we don't have any shortages in the system. It means that our inventory position doesn't go below zero. If it does in real life, we will just ignore that. That's one of the drawbacks of EOQ modeling approach. And quantity order is received all at once in a single delivery. That's also another assumption that EOQ model makes. And EOQ model also assumes that there are no quantity discounts. Remember, we talked about in chapter 15, one of the reasons that companies keep inventories in their system. One of the reasons was economies of scale. Well, so most suppliers, they say, if you order more, I will give you a discount. That's why companies tend to order more. But we assume that that ordering mechanism is not in place with the EOQ modeling approach. Okay, so this is a classical representation of what EOQ does in your system. So let's assume that, again, this is just one product. And on the y-axis, you see how much inventory you have in your system, okay? And then this is just simply the time. So EOQ model assumes that your cycles repeat itself throughout your planning period, especially if you're running an EOQ model. So assume that we order Every time we order a product from our supplier, we order it in a batch of 500 and assume that we had zero, and then assume that we already have it at 500 point. As time progresses, we sell our products to our customers at a rate of 50 units per day. That's why the decrease is a continuous line. It is not like a stepwise line like this, because we assume that the demand rate is fixed, right? Okay. Whenever it hits zero, at this point, our inventory position is zero. We are making another order, and we assume that the lead time for this particular example is, um, a certain days, 3 days. We initiated an order here at the reorder point, right? And then by the time we hit zero, our stocks are replenished right over here back to 500, right? And then the cycle repeats itself. So this time period here, T, is exactly the time period here, and it is exactly the time period here. As you can see, this is, once you know what your Q level is, optimal lot size is, and your optimal reorder point is, then you can come up with this planning mechanism right away. That's one of the advantages, actually the most important advantages of running an EOQ model like this. Okay, so what do we have in EOQ modeling system? So we have several parameters that we have to consider. Well, first of all, we have to know our holding cost, which will be represented as H. We have to know our annual demand level. It's going to be represented by capital D. S is going to be our ordering cost, okay? And you'll say, hey, what's ordering cost? We understand what is holding cost, what is purchasing cost, but you might have difficulty understanding what ordering cost is. Let me remind you one more time that when companies initiate an order, they are already spending too much time on it, investigating it, spending time with multiple codes, analyzing samples, maybe sending people over there for field trips. All those costs are considered under ordering cost. Some call this setup cost as well. Okay, so those terms are used interchangeably. And then Q is going to be our order size, EOQ level, right? And this is going to be the optimal order size. Some people also call this lot size. And we are going to derive a formulation for the optimal Q level. And Q over 2 is going to be the average inventory that we'll be keeping in our system. As you can see, our max position for this EOQ model is going to be Q level, and we assume that Q over 2 is just our average inventory that we keep in our system, okay? And how do we derive it? Well, first of all, let's talk about the holding cost and ordering cost, and you will realize that there's no discussion under EOQ for the purchasing cost, and we don't see any purchasing cost parameter here, and the reason is obvious. Purchasing cost does not matter, because whatever you're going to say, whatever you're going to come up with in terms of order size, you will still have to pay purchasing them, right? So therefore, the purchasing cost is going to be irrelevant in deciding the optimal lot sizes here. Okay, we only need to consider the holding cost, which is going to be, holding cost is Q over 2. This is average inventory times my holding cost, right? And here, this graph is in terms of Q on the x-axis and total cost on the y-axis. And my ordering cost goes down because D divided by Q, actually, remember, D is my annual demand, divided by the lot size. This should give me the number of orders that I make in a year or in a planning horizon, times S. S is the ordering cost. Anytime I give an order, I pay S amount of dollars to initiate that. So that should represent my ordering cost cycle. And the purple line is just addition of this red line and this black line, right? And that would represent my total cost. And you will see that the optimal EOQ occurs whenever this total cost line is at its minimum level, right over here. And this is not a coincidence that it occurs when these holding costs and ordering costs intersect each other right over here. Therefore, this would be our EOQ, or optimal lot size, that we should go with in our inventory planning. So how do we know what this Q star or EOQ is? Well, we know the equations for holding costs and ordering costs. All we have to do is to intersect them and then solve it for Q, right? So, and we see that, EOQ occurs where holding cost is equal to ordering cost. Let's write them. Holding cost is just Q divided by 2 times H. And let's set this equals to D divided by Q times S, right? And let's solve this whole thing for Q. And we see that Q equals to, in square root, 2ds divided by H, okay? This is the equation that we are going to be using all the time to decide our economic size order quantity model.